let's have a look at dilation, and we want to focus on the red boxes. In studying reflection, we place negatives on those red boxes to see the difference in changes in graphs. What we're going to do this time is put numbers. Those numbers are going to change the shape of the graph, and we'll be able to see through some examples. So firstly, let's have a look at the standard graph, which is y is equal to 2 to the power of x. As you know by now, it will look something like this. With the y-cut of 1. And I hope you remember how to work out y-cut, so I won't go through that. Now, if we do 2 times that original function, this becomes a new function. What it will look like, and I'll just use a different color, is this. The shape is slightly changed. And we have this point as 2. Let's compare a couple of more data points just to show you the effects of the dilation. So if we took, for example, x equals 1, equals 1. So at this point, for the y is equal to 2x graph, when x is 1, y is 2. For the other graph, for the 2 times 2x, when x is 1, y is 4. So what can we see from here? We can see that the y-cut used to be 1 and now it's 2. For this data point, x equals 1, it used to be 2 for the y value and now it's 4. It is clear that the original graph has been dilated by a factor of 2 in the y direction, perpendicular to the x-axis. So these are the languages that you have to get used to, because in exam they can say, they can express it in several different ways, and you have to understand that, for example, in the y direction is the same thing as perpendicular to the x-axis. That denotes in which direction the dilation is happening. So that's an example of 2 times 2 to the power of x. We'll have a look at what happens if it's half times 2 to the power of 2x. So let's just try that again. Like that. Okay, so that's the function that we're going to be working with. And similarly, if we had this as the original graph, the half is going to shorten the distance. Right, so it's going to make it wider, fatter. This over here will now be a half, and that's 1. And this distance that you have here, they're all going to be halfway. So that's the whole point of dilating it by a factor of a half. And if you think about it this way, that this was the original graph. Now for every single y value, you've halved it. And that's that explains the direction and how much it's gone down. And that is dilation.